So, last class, what we have discussed about different admixtures, isn't it? Different types of admixtures. Have you got the PDF files? Can you are you able to download the PDF file? Yes or no? Are you able to download the concrete technology book PDF files? Okay, so we have discussed various types of admixtures, and uh, what type of chemicals are used as admixtures. That one we have discussed, isn't it? We have discussed superplasticizers. Okay, let me go to the previous one. Steps of reducing slump loss. Slump loss. Okay, side problems of superplasticizers we have discussed, and other potential problems. Effect of superplasticizer on the properties of hardened concrete. So let's discuss this point. So in a hardened concrete, what do you mean by hardened concrete? That means the concrete which construction is complete. That is your hardened state. Is concrete is said to be in hardened state when uh, that the concrete is already hardened. Already construction is over. Okay, that is called your hardened concrete. And fresh concrete means which is not uh, filled in the construction. That means which is not just made concrete. That is your fresh concrete. Okay. So plasticizers or superplasticizers do not participate any chemical reaction with cement. Okay, or blending material used is concrete. Their action are only physical in fluidizing the mix. Okay, that means superplasticizer did not react with cement, and their main work is to only reduce the water content. Okay, made even the low water content. The fluidifying action has only as long as the mix in plastic condition. One of the effect is absorbed layer is lost. Okay, it can be categorically said that use a right quality of plasticizers or super plasticizers when used in usual small dose. There is no bad effect on the properties or hardener. Only in case of bad quality lignosulfate based plasticizers, it may result in air entrainment. Air entrainment means bubbles, creation of bubbles in the concrete structures. Okay, that is your air entrainment. That means air is entrapped. in the concrete structure, and which reduces the strength of concrete. Since plasticizer and superplasticizer improve the workability, compactability, and facilitate reduction in water cement ratio and thereby increase the strength of concrete. It contributes to the all round improvement of in the properties of hardened concrete. Okay. As a matter of fact, it is the use of superplasticizer which is a pragmatic step to improve around properties of hardened concrete. The use of superplasticizer has become unavoidable material in modern high performance concrete. Here, if you take admixtures, that is in percentage by weight and compressive strength, then we can see the compressive strength, that means strength of concrete rises. In one day, it is again rises in 3 days, and after time, it will again rises at 28 days. That means if we use super plasticizer, we can get better strength concrete, better good quality concrete mix. Okay. After 28 days, it will give full strength. That is why 28 days is given here. See, concrete is given designated like M20. Suppose what is M20? M is the mixer, and 20 is the compressive strength. That already I have told you. Already we have discussed about this strength of concrete, and strength is measured in 28 days. Okay. It has been mentioned earlier that all the plasticizer and superplasticizer exhibit certain retarding properties. These retarding properties do not make significant difference when the dosage is normal. The strength parameter is not reduced beyond one day. But when plasticizers are used in higher dose, the strength development will greatly affected in respect of one day or even 3 days. Okay? However, 7 day strength the beyond, there will not be reduction in strength. The typical strength development is shown in figure. Okay. New generation super plasticizers. So what is the new generation? It is increased workability and changing the mixture composition to reduce the amount of mixing water in order to reduce water cement ratio, which results in increase in strength and durability, and to reduce both water and cement in order to cut cost and incidentally to reduce creep, shrinkage, and heat of hydration. I will tell you what is creep, what is shrinkage, what is bleeding. These are the properties of fresh concrete. When we made a concrete just after the mixing, there are some properties which is called properties of fresh concrete that we'll discuss later. So carboxylated acrylic ester. So that is most common used chemical as superplasticizer. Okay. So we are not going to discuss any more about this in details. Next. So let me show the figure what is showing here. Mechanism of action of acrylic based new generation superplasticizer works on both electrostatic repulsion and static. Okay, a chemical formula is showing here. Chemical reaction is showing here. Superplasticizer content by weight and compressive strength. So can you see in the figure? It is showing that. If you add super plasticizer, it will give better age to the concrete. Okay. Okay. Therefore, super plasticizer are sometimes used for high early strength. The high early strength is generally obtained because of its ability to reduce the water content and therefore water cement ratio which develops high early strength. And secondly, such plasticizers will have such a base that will not cause much retarding effect. Okay, so what is the use of we use super plasticizer in case to attain a high early strength concrete. Okay. Then next is your multi-carboxylate ether. Okay, the new generation super plasticizer. This is also a chemical which is used as a super plasticizer. That is your new generation super plasticizer, which are based on polycarboxylator with the genetic name of multi-carboxylator. MSC is found in suitable in production of high performance component. The properties of the super plasticizer is, so this is another example of super plasticizer chemical multi-carboxylate ether. What are the properties of this chemical super plasticizer? Excellent flowability at low water cement ratio, high reduction of water, low slump loss with time, shorter retardation time, very high early strength, and it works at low doses. Okay, it works at low doses. Next, retarders. What does retarder mean? A retarder is an admixture that slows down the chemical process of hydration so that concrete remain plastic and workable for a longer time than concrete without retarder. Have you understood? See, retarder is that type of admixture after application of which we can uh, use that concrete for a longer period of time. That means it will not attain strength. It will not attain early strength. It will not harden. Okay, it will harden, but slow process. Okay, so if you add retarders, it will give better workable for a longer time and complete without retarder. So retarder are used to overcome the accelerating effect of high temperature on setting properties of concrete in hot weather concreting. The retarders are used in casting and consolidating large number of pores without the formation of hole joints. Okay. They are also used in grouting oil wells. Oil wells are sometimes taken up to a depth of 6,000 meter deep where the temperature may be 200. The angular spacing, okay. Sometimes company may have to place in difficult condition and delay. See, we we are not based on a site condition, based on an environmental condition, we can use retarder. We have to use retarder. Where suppose in you are doing a concrete structure, bridge, it may be bridge or anything in such a situation where that you have to the proper early strength is not required, then what will happen if you not it retarders, it will harden fast and you may not be work on that concrete. Okay, so to make a workable concrete more longer we have used retarders. Okay, sometimes concrete may have to placed in difficult conditions and delay may occur in transporting and placing, isn't it? Some suppose you are in a hilly area. Suppose in a hilly area you are constructing a bridge. So in hilly areas, from the place where concrete are making, that these are called batches where concrete are made, and after that it will carry by a ready mix concrete truck, isn't it? That is your transportation to the site from the place of making concrete. Okay, so it may be longer sometimes because there may be some situations arises where you can stay or whatever, some problems may arise at that situation where transporting time is more. You have to aid retarders. Okay, in ready mix concrete practices, concrete is manufactured in central batching plant. So concrete are may make designed in a plant that is called batching plant. Okay, and transported over a long distance to the job site, which may take considerable time. So, above cases, the setting of concrete will have to retard it. Okay, because it will say if we do not add any retarders or chemicals, what will happen? It will gain strength. It will start hardening. The concrete will start hardening. After that, what? It will not no more use to fill the columns or whatever foundation part, isn't it? So in that case, we have to use retarder so that the concrete, when finally placed and compacted, is perfect in plastic state. So to make the concrete in plastic state, we use retarders. Okay. Retarding admixtures are sometimes used to obtain exposed aggregates locked in concrete. Retarder spraying in surface of form of preventing the hardening of matrix at the interface of concrete and formwork. So, use of gypsum for the purpose of retarding setting time usually recommended when it required. So, we can use gypsum as a retarder chemical. Okay. So, gypsum, we can use gypsum as a retarding material. In addition to gypsum, there are a number of other materials found to be suitable for this purpose. There are stars, cellulose products, sugars, acids, or salts. These chemicals may have variety of actions in different types of cement when used in different quantities. Okay, so we can use stars, cellulose, sugars, acids, salts as retarding material. Okay? So common sugar is one of the most common sugar is one of the most common sugar is one of the most effective retarding agent used as an admixture for delaying the setting time of concrete. Okay. Next, retarding plasticizers. It is mentioned earlier that plasticity and superblicity themselves slow down. Written plastic superblicity category admixtures. Okay, this thing is not required. You just remember what is retarders, how retarding affects, retarding affects the concrete, fresh concrete, why it is used. Okay, that much. Next, accelerators. So what is accelerator? It is just opposite to the retarders. Okay, accelerating admixtures are added to concrete to increase the rate of early development in concrete, to permit earlier removal of formwork, to reduce the required period of curing, to advance the time that a structure can be placed in service, partially compensate for the returning effects of low temperature during cold weather and in emergency repair work. Okay, so in repairing work, we use accelerators. So this is the IS code, IS 9103 1999, physical requirements for accelerating agents. Okay. Next is your, here are some commercial. So in this table, there are some commercial plasticizer and super plasticizer manufactured in India. Okay. So in the past, the commonly used material accelerator was commonly used as accelerating agent is calcium chloride. Okay, CaCl2. So calcium chloride is used as accelerating agent. Okay, if you add accelerating calcium chloride to the concrete mixer, then it will work as an accelerating agent. What is the use of it adding this accelerating agent? It reduces the time, setting time. That means, oh sorry, it increases the setting time. That means it will quickly harden. Okay, after adding accelerating agent, the concrete will quickly harden from plastic to hardened state. Okay, and this type of accelerating agent is used in case of repairing works because we require quickly harden. Suppose in road repairing work, what will happen? If it is one way, then if it is not set, if the setting time is increased, what will happen? It will create any traffic, isn't it? So in that case, road repairing work accelerating agent is used so that it is from liquid state, sorry, so from plastic state to hardened state, it will attain early strength. But nowadays it is not used. Instead of some soluble carbonates, silicates, flow silicates, and some other organic compounds such as trithenolamine are used. Accelerators such as flow silicate and trithenolamine are comparatively expensive. In recent studies, have been shown that calcium chloride is harmful for reinforced concrete and pristine furniture. So calcium chloride is not used nowadays. Some of the accelerating produced these days are so powerful that it is possible to make the cement set into stone hard in a matter for 5 minutes or less. Okay? With the availability of such powerful accelerator, the underwater concrete work, suppose in a river, there is a river and you have to construct a bridge quickly within one month is not possible. Suppose your foundation part is have to finish within 1 month, then you have to sorry, that time we use retarder. So underwater construction has some easy. Similarly, the repair work would be carried out to the waterfront structure. So, in waterfront structure, we use accelerating agent. In the region of tidal variation have become easy. The use of such powerful accelerator have facilitated the basement waterproofing operation in the field of prefabrication. Also, it has become an invaluable material. As this material could be used up to 10 degrees Celsius, defined and unquestionably used in cold weather. Some of the modern commercial accelerating materials like Maxnell OC, Maxnell SDS, Mac torque can be manufactured. Okay. Next is your air entraining admixture. So what is air entraining admixtures? What is air entraining admixtures? It is one of the most important advancement made in concrete technology was discovery of air entrained concrete. Since 1930, there has been an ever increasing use of air entrant concrete all over the world, especially in the US and Canada, due to the recognition of maritime. Okay, air entraining concrete is made by mixing a small quantity of air entraining agent or by using air entraining cement. These are entraining agent incorporate millions of non coalescing air bubbles, which will act as a flexible ball bearings and will modify the properties of plastic concrete. So the air void present in concrete can be brought under two groups: entrained air and entrapped air. Entrained air intentionally incorporated minor spherical bubbles of one size 5 micron to 80 micron. The entrapped air is the void present in the concrete due to insufficient compaction. This entrapped air may be of any shape and size, normally embracing the contour of aggregate surface and training agent, natural wood resin, animal and vegetable fats, oils. These are used as an training agent. Animal and vegetable fats, oils such as tallow, olive oil, and their fatty acids such as stearic and oleic acids. Various wetting agents such as alkali salt, sulfolated organic compounds, water-soluble soaps, resin acids, animal and vegetable fatty acid, miscellaneous materials such as sodium salt or petroleum sulfonic acids. These are used as air entraining agent. The common air entraining agent in USA, Vinchol resin, Durex, deterrent, etc. In India, large scale of use of air entrained concrete is not being practiced. So normally we have not used this type of primarily due to the fact that our frost scaling of concrete is not a serious problem in our country. Okay. Factors affecting the amount of air entrainment. The manufacture of air engined concrete is complicated by the fact that the amount of air entrainment in a mix is affected by many factors. The important ones are the type and quality of air entraining agent, water cement ratio, type and grading of aggregate and mixing time, the temperature, the type, influence of compaction, admixtures, and other entraining agents. Okay, what are the uses of this air entraining? Air entrainment will affect directly the three properties: increased resistance to freezing and thawing, improvement to workability, and reduction in strength. Okay, resistance to freezing and thawing. These things are not required. So here is a figure. Air entrainment increases the durability of concrete in snowbound region. Effect on workability. How does it affect on workability? Effect of scale, effect of strength, and next admixture is your pozzolanic or mineral admixtures. Okay? The use of pozzolanic materials is as old as that of the art of concrete construction. Okay. So specimens of concrete are made by the volcanic acid. Well, if you use pozzolanic or mineral admixtures, what will happen? Lower the heat of hydration, increase water tightness, reduce the alkali aggregation aggregate reaction, improves resistance to attack by sulfate salts in seawater, lower susceptibility to dissolution and leaching, improve workability and higher cost. And what are the pozzolanic materials used as an admixtures? And the reaction can be pozzolan plus chemical hydroxide plus water. It will form a gel. Okay. Natural pozzolana, clay, cells, opanic shards, diatomaceous arch, volcanic tuffs, pumicite, flies, furnace flakes, silica fumes, rice husk as, metal conic surki. These are artificial pozzolana. So here is a fly ash is given. What is fly ash? It is a finely divided residue resulting from where? From the combustion of powdered coal. Generally, in coal production, got we have collected the fly ash from there and transported by the flue gas and collected by electrostatic precipitator. Okay. Scanning of electromagnetic micrograph class F fly ash. The use of fly ash in concrete admixture not only extend the technical advantages to the properties of concrete but also contribute to the environmental pollution control. In India alone, we produce about 75 million tons of fly ash per year, the disposal of which has become a various environmental problem. So in this figure, it is showing a Rihan irrigation project of Uttar Pradesh, where fly ash was used for the first time in the construction of this irrigation canal. Okay, so in this figure, it is irrigation canal is showing where fly ash is used first time, replacing cement up to 15%. Okay, so we can replace cement by fly ash like 5%, 3%, 10%, 15%. So here, this canal is constructed. This irrigation Canal is constructed by using fly ash up to 15%. Okay. There are two ways that flies can be used. One way is intergrind certain percentage of flies with cement clinker to factory, or second way is to use fly ash as admixture at the time of making. So fly ash we can use at the time of cement making process also in the manufacturing of cement. While manufacturing the cement, we can use fly ash directly, or we can use while making concrete. Then also we add fly ash as admixtures. Okay. Next is again fly ash is classified as a class F, class C, like that. Fly ash and tested according to method. The IS code for fly ash is IS 1727 Oh, sorry, 1967. Effect of fly ash on fresh concrete. So here another example is given. High volume of fly ash has been used in the Barker Hall project, University of California at Berkeley in the construction of sewer wells. Here high volume of fly ash is used in that construction. Okay, influence of fresh concrete. Influence of Surkey. There is a Fakranangal dam showing here. What is Surkey? Surki is another material we can use as your pozzolaning material. Surki is an artificial pozzolani made by powdering bricks and burnt clay balls. Okay, Surki is nothing but powdered brick which is burnt. Burnt, if you burnt brick and powdered it, that is your Surki. Okay, if you burnt brick and make powder, then it will be your surki, which can be used as pozzolanic material, pozzolanic admixtures. In some measure of a large scale purpose, surki clay. Okay, so in this Bhakra Nangal Dam, which is situated in, I think you here Bhakra Nangal Dam is situated in the Himachal Pradesh. Okay, so, scientifically made surki was used. Remember, this is a example of using surki in India in the construction of Vakranangal Dam. Okay, here they use 100 tons per day at the rate of 20% cement replacement. Okay, they have used surki, that means burnt clay powder, as pozzolaning material. Okay. Okay, what is the next? Ground glass furnace and distinction bond. Main topic we will discuss here, okay? Not the whole book. Alkali and workability and so okay, let me uh, check the next chapter. What is the next chapter? Fresh concrete. Okay, next chapter we will discuss about some more admixtures and after that fresh concrete. Here we will study workability, segregation, bleeding, setting time of concrete process of manufacturing, slum, what is slum, how water's workability is measured. Okay? Okay, thank you. 26 participants. Okay, thank you.